Welcome to the answers to holiday maths number 4. So we're going to do a bit of coordinate geometry. We're told that a line passes through the point 2,5 and has the gradient minus a half. We're going to find an equation of the line giving our answers in the form y equals mx plus c. So nice straightforward start. Y is equal to minus a half x plus c, and then we substitute our point in, which is 2,5, to find c. So we have 5, which is y, is equal to minus a half times 2 plus c. So 5 is equal to minus 1 plus c. So c must be equal to 6. And to finish off, we've got y is equal to minus a half x plus 6, and that's 3 marks. I think probably the largest danger there, the biggest thing that people get wrong, is they get their x's and y's mixed up when they substitute. Now we get a point for showing that b lies on the line. So here's b, so we're just going to substitute minus 2 into the line equation and see if 7 comes out. So y is equal to minus a half of minus 2 plus 6, which means that's 1 plus 6, which is 7. So QED, it has been demonstrated. And now we're going to find the length of AB. So they've told us A, which is 2,5, and they've told us B, which is minus 2, 7. And I'm just going to draw a little sketch of it. So here's B, minus 2, 7. A is going to be over here somewhere, and then length of a line segment is Pythagoras. So the difference in x values is a difference of 4, the difference in y values 5, 6, 7 is a difference of 2. So the length is going to be the square root of 2 squared plus 4 squared, which is equal to the square root of 4 plus 16, which is root 20. And notice we're asked to give it in this form, so root 20 is the square root of 4 times the square root of 5, and square root of 4, as we all know, is 2, so it's 2 root 5. And there's 3 marks for that. Now, this is the hardest part. 4 marks for this. So the point C lies on L1 and has an x coordinate equal to P. So we know that C has got an x coordinate that is P. Now, just to remind you, the line equation was y is equal to minus a half x plus 6. So if x equals P, then y is equal to minus a half P plus 6. So that's our other coordinate. And that's C, and we already know what A is. A is 2,5. So I'm just going to use Pythagoras on that. The length of AC is equal to the square root of 2, because that's the x coordinate here, minus P, because that's the x coordinate here, squared. It doesn't matter which way around you do it, of course, because the sign will be squared away. And then we're going to add the difference of the y coordinates, so that's going to be 5 minus this one here, which is minus a half P plus 6. And we square that too. And it's just a question of keeping our nerve and doing this. So we've got, if we square both, now actually sorry, the length of AC we should have noticed is actually 5, so we're going to replace this with 5. In fact, I'm going to replace it with 25 because I'm going to square both sides, which leaves me with 2 minus P squared plus 5, and then I'm going to multiply this out, so minus, so it's going to be plus a half P minus 6 squared, which is, this one here is going to multiply out to 4 minus 4P plus p squared, and this one still simplifying, 5 minus 6, so it's going to be a half of p minus 1 squared. So we've got 4 minus 4p, so 25, don't forget, plus p squared plus a quarter p, and then it's going to be minus p plus 1. And now it's just time to tidy it up really, so we can subtract the 25 over, so 0 is equal to, now I've got my p squared, and then I've got minus, so that should be squared there, shouldn't it? So here we got, p squared and another quarter, so that's, just rub that out for a moment. So a p squared and a quarter p squared is going to be 5 quarters p squared, so that's that and that. And then we've got a minus 4 and a minus 1, so that's going to be minus 5p, so that's that term and that term taken care of. And then we've got a 4 and a 1, which gives us 5, but then we're subtracting the 25. So I'm just going to multiply it through by 4 to get rid of the fraction, so 0 is equal to 5p squared minus 20p. Now I'm just going to observe that these two here, they turn out to be minus 20, and if I multiply it by 4 I get minus 100. I don't, I get minus 80. Oh dear, right, it's going well tonight, isn't it? Never mind, minus 80, that's better. And now I'm going to divide through by 5, so I get 0 is equal to p squared minus 4p minus 16, which is actually what they asked me to show. So that's my final answer, and again it has been shown. There we are. Let's move on to the core 2 bit, finding the area under a curve, and isn't that a beautiful curve? It looks like you have a flag on top to me. There we are, let's have a flag on top of that. And what else should we have? Maybe have somebody skiing down it, I think, perhaps. There we go, with some ski sticks. Right, so now we've done those important things, let's see what it asks us to do. So we've got a curve, there's our equation, and it intersects it there and there, so we can see that on the picture. Calculus to find the exact area of R. So this is just saying calculus means integration, basically. So very straightforward. Notice it's all a positive area, so we can do it in one go. So the area under the curve is going to be given by the integral from minus 1 to 4 of 1 plus x brackets 4 minus x with respect to x, and that came from the curve here. And then we just can head off now quite happily. Minus 1, 4, and I'm going to multiply it out. So 1 times 4 is 4, then we've got minus x plus 4x minus x squared with respect to x, and from there I can actually integrate now. So I think I'm just going to tidy it up first actually, so we'll stay like this in this form for a little longer. So we've got 4 plus 3x minus x squared with respect to x. Now notice the integral sign stayed here, and now the integral sign is going to go, and that's because I'm actually going to integrate. So 4 goes to 4x, and then it's plus 3x squared over 2, so the power goes up and you divide by the new power, minus x cubed, the power goes up and you divide by the new power, and put the limits in. And there's no plus c here because of the limits. So that's the integration done, and now I'm just going to substitute in the limits into it. So I've got 4 times 4 plus 3 times 4 squared over 2 minus 4 cubed over 3, and then I'm going to subtract the whole lot with the minus 1 put in. So 4 times minus 1 plus 3 times minus 1 squared over 2 minus minus 1 cubed over 3. And it's core 2. With greatest of care, you'd stick that on your calculator and you'll get 125 over 6, or at least I did. And that is the end of today's little bit of mathematical fun. What should we have there? There's a sword and a shield. And I'll see you for some more tomorrow.